Hello friends, today we will see next property, that is the circular time shift property, where the statement is understanding the circular time shift of a signal. If we have a DFT pair of xn and xk, then if I take a DFT of a circular shifted signal, which is represented by double brackets with n and the suffix, this is equal to e raised to minus j2 pi km by n multiplied by x of k. So this is the statement. So now we have to keep it in mind that we have the knowledge of the circular time shift with that of the linearity of the linear shift of the signal, how it is related with the circular shift. So that we want to have it in our mind so that we can prove this property. Now the proof starts like this. We have to find the DFT of x circular n minus n. This is the circular shift with the value of shift is n. This is written as 0 to n minus 1 circular shift n minus 1 for the order n e raised to minus j 2 pi n k by n. Now I will break n from 0 to n minus 1 to n is equal to 0 to m minus 1 and m to n minus 1. So this is the break that I have introduced. So this is one step we have to keep it in mind. Now coming back to this equation, so I will put my first break limits m minus 1, where I am still having my circular shift of order n into e raised to minus j 2 pi n k by n, plus I have the first limit. The second part will be n is equal to m to n minus 1, and the signal remains the same. Okay, its signal and equation remains the same. Now, because I will call this equation 1, we can't take this circular shift as it is. We have to relate it with the linear shift, and it is equal to n minus n. That is, we can say n minus n, like this. So if I will simplify this, it will be x of n minus m. This is n. Okay. N minus m plus can say plus this is the way it is related. If you see the circular nature of the signal and the linear relation. N plus n minus m. Okay. Now we will modify our equation. I will call this as part 1 A B. Now I will take this A part here and I will go for rewriting the equation. N is equal to 0 to m minus 1 x of this has come with is equal to summation n is equal to 0 to m minus 1 x of n minus n plus n e raised to minus j 2 pi n k by n. Let n minus n plus n is equal to L. Okay, this is our reduction form. So when this is there, when n is equal to 0, L will be n minus n. When n is equal to m minus 1, n is equal to m minus 1, what will happen? M minus n plus n minus 1. So this becomes n minus 1 and n getting cancelled. The new values of L will be n minus m and L minus n minus 1. Now the equation will be changed as summation L is equal to n minus m to n minus 1 x of L e raised to minus j 2 pi by n k. Now n is changed as the n value will be, you can just rewrite here, n minus n plus n is equal to L. So, n will be replaced as n plus n minus n. Okay, this I will write as n minus n plus n plus L. Rewrite it. E raised to minus n plus m plus L multiplied by k. Now we are out of this. So we'll just have some reduction with this. L is equal to n minus m, n minus 1 x of L e raised to minus j 2 pi by n into m plus L. Now what has happened to this e raised to plus j? I have split like this 2 pi k by n into n. Now this value, since e raised to j 2 pi k equal to 1 for all k. Okay, so this will be for all k. Summation L is equal to n minus n minus 1 x of L e raised to minus j 2 pi by n plus L. Okay, so this becomes equation number 2. Now from B, we have summation n is equal to m, n is equal to m to n minus 1 x of circular n minus m, which we had taken as the second split, 1 by n. This will be equal to, now here what I will do is put new values. No? Now we have n minus m plus n is equal to L. So when n is equal to m, what will happen to this limit? L is equal to n. And when n is equal to n minus 1, L will be, n minus 1 will be 2n minus n minus 1, which can be taken as n minus m minus 1 because it is periodic, as periodic. Okay, so this becomes, first I will write this, the new value of n will be n, next value will be n minus m minus 1 x of L e raised to minus j 2 pi k by n. What is the value of n here? N will be taken as m plus L. You can see, because as similar way this is going to give you, already we have done this, n minus m plus n is equal to L. So L will be equal to L plus n minus n. So this value. So when you go for the simplification, you see that this is going to give you a 1. So that already in the first part it has been covered. So that is the reason. So L is equal to n minus m minus 1 x of L e raised to minus j 2 pi k by n into m plus L. This is equation number 3 from 1, 2 and 3. DFT of circular shaft is equal to summation. The first part was n minus m to n minus 1 x of L e raised to minus j 2 pi k by m plus L upon n plus this term L is equal to here 1 removed, so this becomes a 0. 1 n has been removed, is it not? So cancelling 1 makes it 0. L is equal to 0, n minus m minus 1. This becomes x of L e raised to minus j 2 pi k m plus L by n. Now we can see the limit. This is the first part, first break, the second break. You can see L is starting from 0 to n minus 1, then n minus n to n minus 1. So the total limit will be L is equal to 0 to n minus 1 x of L e raised to minus j 2 pi k m plus L by n. If we can, because my variable is L, so other things I am not interested. So I will split this as L is equal to 0 to n minus 1 x of L e raised to minus j 2 pi k m by L into e raised to minus j 2 pi k L by n. So this is my constant. So that will come out minus j 2 pi km by n into x of t. So that is what the proof is. Hence proved.